In this problem, we're trying to find slope between 2 points. So we've got x here and x plus h is there. Those are my 2 points. And so here's our graph of our line right here. This is our function, f of x. It goes all the way up to there. And we're looking for the slope between these 2 points, this point and this point. Why is that? Because at x, right, the y value is right here. You can see f of x, right, the function's value at x is right there. And at f of x plus h, right, go up here to the function, and there's the function's value, f of x plus h, right, the function evaluated at x plus h. So we're going to find the slope between the points x, which is here, and x plus h over there. So it's going to be y minus y divided by x minus x, right, because that gives us the average slope between those 2 points. Now we see that because the points are so far apart, the average slope, which is a straight line, it's just the average between those 2 points, which is a straight line between points, is not the same thing as the slope that you see on this function. Because the slope is on, you see what's right here, and the slope here would be like that way, right? And here's the average slope is that way. So as long as these points are so far apart, it's a really bad way to find the slope at a particular point. But as you move these points closer and closer together, closer and closer and closer and closer until you get right down to the very one point. So if the h is just a tiny little bit beyond the x, right? So x is here, and x plus h, instead of being over there, if it was way up here close to the x, your slope would be the same for the straight line and for the curved line. And so that's what we're looking for. We're looking for what happens when h goes down to 0, the difference between the first point and the second point, x and the x plus h goes to 0, so it's just x. And you just have that slope at that one point.